Hello and welcome to the lesson. The question reads, the equation of a curve is given as y is equals to a third x cubed, subtract a half x squared minus 2x minus a third. A. Find part 1, the value of y when x is equals to negative 2. So to find the value of y when x is equals to negative 2, we shall simply substitute this value of x in this function. This is how we're going to do it. So y is equals to a third, then in place of x you're going to put negative 2, so negative 2 cubed subtract a half, this is a negative 2 squared, subtract 2, negative 2 minus a third. Simplifying these, shall have a third multiplied by negative 8 minus half, this is a 4 minus this would be negative 2 multiplied by negative 2 would be positive 4 minus a third. So simplifying these, again we can just use the calculator to complete these. So inputting all these values in the calculator, a third, this third multiplied by negative 8 minus a half, this is plus 4 minus a third, this will give negative 1. So y is equals to negative 1. So that is the value of y. Let's go to the next part of the question, that is the second part. The equation of the tangent to the curve at x is equals to negative 2. Now the equation of a tangent is a line, and to get the equation of a straight line we require to get the gradient, and at least we should have at least 2 points. Now we're going to start by getting the gradient of this tangent. To get the gradient we shall differentiate the function, this function of y, the equation of the curve. So let me just write the equation of the curve here. It is y is equals to third x cubed and minus a half x minus 2x minus 1. So we are going to differentiate this function, this y, with respect to x, and that will give us the gradient function. So let us proceed. So differentiating these, we get 3 multiplied by a third x squared, then subtract, and this is squared here, this is squared, the square there, so 2 multiplied by a half multiplied by x, this is subtract 2. So when we differentiate a third x cubed, this is what you get. When you differentiate a half x squared, this is what you get. When you differentiate negative 2x, we get negative 2. So this will give x squared subtract x minus 2. So this is the gradient function, the function that is going to give us a gradient. So at x is equals to negative 2. To get the gradient at x is equals to negative 2, we shall substitute this value of x, that is negative 2, in the gradient function. These are you going to get. So x squared negative 2 squared subtract x is negative 2 minus 2, and these will give the gradient of this tangent at this point x is equals to negative 2 as 4. So that is the gradient of the tangent. Now to get the equation of that tangent we require another point. We already have this point at x is equals to negative 2, y is equals to negative 1. We already obtained that in the first part. So this point, therefore, written in coordinate form will be negative 2, negative 1. So to get the equation of this tangent now, we already have the gradient. We have 1 point. You can use various methods. You need to write it in the form y is equals to mx plus c. So let me just use the method. You can introduce another general point, like so you take negative 2, negative 1, and introduce another general point on the line xy. This is just one of the methods. And having the gradient as 4, use these 2 points x, y, and negative 2, negative 1 to calculate the gradient. So the gradient will be y, change in y, y subtract negative 1, which is y plus 1, divided by x subtract negative 2 will be x plus 2 is equals to 4 over 1. So cross multiplying these, you get y plus 1 is equals to y plus 1 is equals to 4 into brackets x plus 2. So y plus 1 is equals to 4x plus 8, and this one will give y is equals to 4x plus 7. So that is now the equation of the tangent to the curve at that point. The last part of the question: determine the coordinates of the turning point of the curve. How do you know the turning point of the curve? At the turning point of the curve, the gradient at those turning points is supposed to be 0. So that is something that is very important. So at turning point of the curve, the gradient, which is given by dy of dx, is equals to 0. The gradient is 0 at the turning point. So we need to obtain the gradient function, since we had already differentiated the curve to get the gradient function, and at the turning point the gradient function is 0. So we already got these, the gradient function as x squared subtract x subtract 2. It was like that. So at the turning point, this is supposed to be equated to 0. And you notice that this one forms a quadratic equation. So when we solve this quadratic equation, we shall get two values of x. Two coordinates. The x coordinates will be two values of x, and those two values of x are going to assist us to get the corresponding values of y, and we shall get the points. So let us solve this equation. You can use any suitable method. Let me use factorization. Get two numbers whose product is negative 2 and the sum is negative 1. These numbers are negative 2 and 1. So this will give x squared negative 2x plus x minus 2 is equals to 0. So therefore we shall have x subtract 2 plus 1 x subtract 2 is equals to 0. So this will give x plus 1 x minus 2 is equals to 0. At this point, x plus 1 is equals to 0, and if this is the case, x will be negative 1. That is the first x coordinate, the turning point. And then we have x is equals to 0, x minus 2 is equals to 0, and this x is equals to 2. That is the second x coordinate. Now those are not the points, those are just x coordinates. Now we should get the corresponding y coordinates, and to get the y coordinate we shall substitute these values in this function. So y is equals to a third x cubed minus a half x squared minus 2x minus 1. So this function, when we substitute these x coordinates, these values of x, in these we shall get the corresponding y values. So let's go directly to the first one. So when x is equals to negative 1, y will be given by, we just substitute here, just substitute. So y, the value of y, so just use calculator to do these. Just need to use the calculator to do these. So a third negative 1 is half 2. So these will give 5 over 6. So therefore, when x is equals to negative 1, y is equals to 5 over 6. So the first value, the first turning point is negative 1 and 5 over 6. That is the first turning point. The second one, we shall obtain that one when x is equals to 2. So what will be y? So y is equals to, again we substitute in this function, is x is equals to 2. So this one give this is a third to brackets 2 cubed minus as a 2 to negative 1. This will give negative 11 over 3. Negative 11 over 3. So that is what you get. So therefore the second turning point when x is equals to 2, y is equals to that. So the second turning point is 2 and negative 11 over 3. So those are the two turning points, and that is simply how you're supposed to solve that question.